Yeah, hi guys. After a very long time, I am going to present velocity time graph. This is all about. This is related to motion in one dimension. Okay. So before to that, I would suggest you guys to go through chapter 8 motion. You please browse through my playlist on my channel. You will find a chapter that is called chapter 8 motion. So here I have covered the basic concepts related to motion, uh, different types of graphs, uh, derivation of equation of motion, and numerical, lots of numerical questions I have solved. So I have recorded this particular chapter in multiple parts. If you go through, I strongly recommend you to go through. So it will give you very good clarity about what is motion, right, and what all things we can calculate out of knowing the motion of any object. So today on the same line we are going to discuss about velocity time graph. Velocity time graph for a motion of an object in one dimension. I repeat, we are going to talk about velocity time graph and its different applications for an object which is traveling in one dimension, right? But the direction of the motion is constant. So velocity time graph. So velocity I am showing on the y-axis. We should in which unit you are going to deal it, right? So it is meter per second, and then we are representing time on x-axis, right? Just a minute. So time on x-axis. So time again I have taken in second. So I prefer to take units in SI units. Velocity I have taken in meter per second, and time I have taken in second, which is SI unit of velocity and time respectively, right? So we are going to understand what all things we can get out of velocity time graph, how velocity time graph is important for us, and what all information we can extract out of velocity time graph. So first thing which we should know, which we can do is, with the help of the velocity time graph, we can get to know about the acceleration of a body, right? Acceleration of a body. So I am calling acceleration as this. Acceleration is a vector quantity, so I am putting an arrow above A. So that indicates that acceleration is a vector quantity. So we can calculate acceleration of a moving object from velocity time graph. How to calculate acceleration? How we calculate? It is nothing. It is simply slope of. You can calculate the slope of velocity time graph. I am calling in short VT graph. Velocity time graph. Okay. So here, if we go through the velocity time graph, so we can comment about uh, the whether the car is accelerating uniformly, it is not accelerating, or it is traveling with uniform velocity. Uniform velocity means when an object is traveling with a uniform velocity, that means acceleration is zero, because acceleration is rate of change of velocity, right? Acceleration is rate of change of velocity. So if we go and analyze this part AB, here we can say this is the slope, right? And this is a straight line. So here slope you find here, everywhere it is same, right? So AB, you can say that, okay, AB part is uniformly, AB part is showing uniformly accelerated. AB part shows uniform acceleration. Uniform acceleration. Okay, uniform acceleration, because the slope is constant, right? I will calculate it more. What this BC part tells you? It tells you that in some time, right? Probably from 8 to 10 seconds. This is 10. From 8 to 10 seconds, the velocity dropped to 0. So it shows uniform retardation. It shows uniform retardation. Retardation is nothing, it's a negative acceleration, right? When a car is uniformly retarding, means its velocity is uniformly getting reduced at a uniform rate. It is getting reduced at a uniform rate, at a constant rate. Here also it is getting reduced, and here, and this part, if you see, so there are two parts of this velocity time graph. This part is lying, this triangle ABC is lying above the time axis, So this represents positive displacement. Positive displacement means a car is moving away from its starting position. This is the starting position, okay? So car is moving away from the starting position. So that is indicated by when the graph lies above time axis, right? What happens when the velocity time graph lies below the time axis? That means car is traveling towards the starting position, or you can say car is traveling in the opposite direction. So if you, as per the direction convention, if you go and if you take this as positive, this you are bound to take negative, right? Yeah. So this part will give you negative displacement. This part is again positive displacement, right? So we will discuss different parts. Let us calculate the acceleration from this part. If I ask you to calculate acceleration during part A to B, so what we require, how to calculate the acceleration? So we can calculate it this way. We are supposed to drop. And here it is matching with 5, right? So this, let us say this point is A. So acceleration is slope, right? Slope. What is slope? Slope is y by x. What is the value of y? Y means height, right? So height is 5. And what is x? X is 8, right? 5 by 8. 5 by 8. What is its unit? The unit of y is meter per second. So unit wise, if you go and check meter per second, right? You are dividing it by x. X is time. So meter per second, you are dividing it by second. So what you are going to get? You are going to get meter per second per second. We call it acceleration, right? So here we can write meter per second per second. So this is how we can get acceleration. So during AB part, it is accelerating. Can we calculate acceleration during BC part? Yes, let us calculate. How to calculate that? That is again the slope, right? This time it is again y by x, right? So what we have to do is that this time the slope is this one. This becomes negative slope. This is negative value. So basically what we have to do, final velocity minus initial velocity, right? If you do final velocity minus initial velocity, because acceleration is rate of change of velocity. So final velocity is corresponds to final time instant, right? We can say t2 minus t1, no problem. So here let us calculate what is the final velocity during BC. It drops to 0. And what is the initial velocity during this part? 5. Final time stamp is 10. Initial time stamp is 8. I repeat, I am analyzing the part BC of the curve, part BC of the graph. Okay. So in this duration we are getting minus 5 by 2, approximately minus 2.5. Again the unit will be meter per second per second. So in this case it is uniformly retarding. Uniform retardation. This is a case of uniform retardation. This is a case of uniform retardation. Retardation is nothing. It's a negative acceleration, right? That means the velocity is dropping uniformly at a uniform rate to 0. Right. So similarly, this is the first thing we can get from velocity time graph. We can calculate acceleration of any part of the graph. What else we can calculate? We can calculate, second thing is total displacement. You say a total displacement or net displacement, whatever, right? So we all know that displacement is a vector quantity. So net displacement or total displacement is what? What is net displacement? You call it net displacement or total displacement? It is something. So I'm saying it's a net displacement. If I say, what is the net displacement? Net displacement is equal to C. Now let's park this thing for a while. I'll come back here again. If you go and calculate the area of any shape, whether it is a triangle or it's a trapezium, right? You calculate area of any shape, triangle, trapezium, right? You are ultimately multiplying y into x. You are doing y into x. I will explain it in detail. Y into x. What is the unit of y? Y represents meter per second, right? And what is represented by x? S. So ultimately, what you are going to get? Meter, right? So the area under velocity time graph gives you displacement. So and net displacement is, as I said, net vector quantity is vector sum of the constituent vector quantities. Okay. So net displacement is vector sum. It is vector sum of the constituent vector constituent displacements. Okay. So right. So here net displacement, what we are saying? We are saying that vector sum means area, the direction makes sense. The area, if the area is lying below the time axis, we are going to subtract that particular area, right? If the area is lying above the time axis, we are going to add that particular area. I repeat, if the area lies above the time axis, we are going to add that area, and if the area lies below the time axis, we are going to subtract that area, right? So in this case, net displacement, it's a vector sum. Vector sum means you have to take into account the direction. You have to take into account the direction. So what is the net displacement in this case? This is area of triangle ABC. Area of triangle ABC. Now this area we will subtract. Yes, so we will do minus and we will say area of trapezium. Trapezium CDEF. CDEF. Okay. And this area is again, it is going to be plus area of trapezium, area of trapezium FGHI. FGHI. Now are we clear why we have done minus and plus? Minus I have done because this area is to be subtracted, and plus we have done because this is lying above the time axis, so this has to be added. So now we can find out the area of triangle ABC. Let us calculate. What is the area of triangle ABC? Half into base into height. What is the base? Base is 10. Base into height. Height is 5. Right? This is something which is calculable. And now again, what we are going to do here is area of trapezium CDEF. So it is half into sum of the parallel sides. Sum of the parallel sides. So this area is what is the length of this? This side and this side is parallel. You can say, right? So this is 25 minus 10, half into 10. Sorry, half into 15. 25 minus 10, half into 15 plus this approximately is, you go and take it as, we can take it as approximately 8, because take it as 8, right, or 9 you can take, right. Now sorry, we have to take the height also. Height is again 5. Height is again 5. Okay. Now plus half, this is again a trapezium, sum of the parallel sides, half into sum of the parallel sides. So 38 minus 25 it gives you 13. So 13 is the length of this FI. And what is the length of GH? Approximately it seems it is, let us say it is 6 unit, right, or 7 unit, just to make the calculation easier. So now we can calculate it. 5 into 5, 25, right? And here we can calculate 15, 9, 15 plus 9, 24, 24 by 2, 12, 12 into 5, 60, plus 13 plus 7, 20, 20 by 2, 10. So we are going to calculate the net displacement. That means it is coming minus 25 meter, right? In this case, displacement is coming minus 25. Oh, sorry. Again, I made a mistake. I'm extremely sorry for that. Oh, I made a mistake. Everything is correct here, except I have not put the value of the height. Sorry, I must put the height. So the height is same as 5, right? I should multiply it by 5 as well, right? So now, so half into 13 plus 720, right? 10, 50. It's going 50. 50 plus 25, 75, 75 minus 60, 50. So the net displacement